Now in this video, we're going to continue with using either current division or voltage division to solve certain problems. Now the question says, determine I/O in the circuit. So where is I/O in this circuit diagram? Well, we know I/O is going to be the current flowing through this 12K resistor here, right? So how are we going to find I/O? Well, we know the current coming into this node right here, that's going to be 12 milliamps. And we know once the current enters this node, it's going to split. So it's going to come this way and it's going to go that way, right? So once it splits, then we know that these two resistors are actually going to be in parallel. We're going to have to find the equivalent resistance for this side of the circuit. So let's begin. When we look at these circuits, we have to fundamentally understand what's happening with each circuit. So we have a current source, which means current is going to flow in this direction here, right? Once this 12 milliamp of current reaches this node right here, it's going to split. Therefore, some of the current is going to come this way, and some of the current is going to go this way. Now, in order to find the current I/O, which is the current in this branch here, we can do a number of things. You can do KCL right here. Maybe you can do KVL, right? So there's so many things you can start off with. Now, right away, when I look at this circuit diagram, I see that I can reduce this side of the circuit, right? We have these resistors in parallel. So right away, I can just reduce this circuit to be a little easier to look at, right? So I know these two resistors are in parallel, so I can say 12 times 12 over 12 plus 12, that's going to give me 6 kilo ohm. So when I redraw this circuit now, I'm going to have something that looks like this. This is 12 kilo ohm. We're going to have a 6K up here. And we know we're going to have a single resistor, which is going to be 6K. So you have 6K ohm. And from this parallel combination, we're also going to have 6K here. Now, when we look at this, we know the current, I/O, and that's what they want us to find, is still going to be through this branch right here. So we have I/O. Now, when you look at this, you can say, all right, well, we know these two resistors are in series, so we can simplify that to one resistor instead of having two. We have 6 plus 6. That's going to give us 12 kilo ohm. So we can reduce this circuit once again. We know this is 12 milliamp. We have a resistor here. And that's 12 kilo ohm. And then we have another resistor which is going to be in parallel, and we know that's going to be, and that's also going to be 12 kilo ohm. So this is going to be our circuit for this particular problem. Alright. Now when you look at this, you know the current I/O is still going to be through this branch here, right? So it's still going to be the current I/O through this branch. And we can call this current I1, right? So now when we look at this, something interesting is going to happen here. Because these two resistors are in parallel, and we know the current source that's going to split to give us these two currents for these resistors that are in parallel, we can just use current division to find the current I/O. Do you see that? So we can say I/O equals IS over the opposite resistor, which is going to be 12. So for this one, I'm just going to write it as R1 over R0 plus R1. IS, which is the source, is going to be 12 milliamp. I'm going to say I/O equals 12 times 10 to the minus 3, open bracket. R1 is going to be 12,000. R0 is also 12,000 plus 12,000, which is R1 again. So when we simplify this now, we're going to have I0 equals 12 times 10 to the minus 3 over 12,000 over 24,000. Now when we put this in our calculator, we're going to get, therefore IO is going to equal 6 milliamps. So this is going to be the answer for this particular problem. IO equals 6 milliamps. So all we did is we combined these resistors. These two were in parallel. Then these two were in series. So we had two resistors in series. And we knew the current source. Therefore, all we had to do at that point was perform current division to find the current through one of those branches. This is basically it for this problem. Like I said, there are multiple ways you could have probably solved this particular problem. But this is the way I went about it. Maybe there is only one way to solve this problem, right? Who knows? But like I said, you're just going to learn these techniques, right? And you need to have them in your bag. And you must be able to identify which one you should use. So you might be saying, well, let me use KVL here. But then as you look around, you realize you don't know this voltage. So you might be stuck with KVL. You might say, let me use KCL. So you might use KCL here. But then notice, wait a minute, I don't know the current in this branch or this branch. And then you might be stuck once again. So, like I say, you just have to be able to look at these things and understand what's happening here. If you can simplify a circuit by combining resistors, by all means go right ahead. Because if you can combine those resistors, you're going to make your life a little easier. Because at that point, you're just using the different tools in your tool bag in order to analyze and solve these types of circuit problems.